Okay, so we're given an n by n integer matrix with the following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. So just looking at the grid they give us, we can see that it's just going to always be increasing, right? So the first row, each element in the first row is increasing. The next row is going to have start with an element, right? Its first element is going to be greater than the last element of the previous row. So they mean that it's just increasing like this, right? Through the whole grid. So we're also given an integer target. They want us to return true if target is in the matrix. If it's not in there, they want us to just return false. Um, our solution has to be in logarithmic time complexity. So it's got to be in big O of log m times n time complexity. So they just give us the time complexity that it has to be in upfront, right? So what does this look like, right? If it's not already popping out, it should, right? So we have this data structure which is sorted. They want us to make an algorithm that finds something in that data structure in logarithmic time. So that's a binary search problem, right? Logarithmic time sorted input, like definitely binary search. Because just again, with a binary search, with each iteration of a binary search, you're cutting the search space in half, as opposed to with linear search, where you just be knocking off one element off the search space, right? So logarithmic time complexity is much linear. It's much better than linear time complexity, right? It's much quicker. So it is favorable, and yeah, we don't need to do any we don't have to traverse the axes simultaneously and do any like weird wizardry. Like I think this problem becomes a little bit easier once you understand that you can break it into two pieces. So we're actually going to do two binary searches in sequence. The first binary search is going to be to find the row that our target potentially is in or potentially isn't. Then we're going to follow that up with a second binary search on that row to either confirm or deny that the target is in that row, right? And then finally, once we've done potentially two binary searches, we can return either true or false depending on if we've seen the target. So yeah, let's just go ahead and code that, right? So we're going to do two binary searches in sequence. We can do this in place, right? We're not going to use any extra memory. So the space complexity for this will just be constant. We're going to need for our binary search, it's kind of like a 2 pointers problem, right? So we need a left pointer, which is just going to be 0. We also need a right pointer, which is going to be the basically the position of the last row in the matrix, right? So that's going to be matrix dot size minus 1, right? Because first we're going to search for the row, right? Now, how are we going to do that? We basically are taking advantage of this sorted structure, right? We can check for any row whether a given number is within that row, before that row, or after that row, right? We can check the row and know for sure which one of those three is the way to look, right? Because we can check the first element of the row, right? And we can basically compare the target with the first element, right? Is the target less than this first element here? If it is, then we can just search this first half of the grid, right? If it's greater than the last element, we can search the remaining portion of the grid. And finally, if it's neither greater than the last element nor lesser than the first element, we know it has to be in that row. So we will then say that we have found the row which the target is potentially in, right? And I say potentially because we have to confirm that with the second binary search. So okay, so we're going to have a integer as well for the midpoint. We don't know what that is yet. We also want a Boolean to keep track of, to basically tell us, did we find our row? So I'll just say did find, that will be false because at the very beginning, we haven't found it. So we're going to loop while our right pointer is greater than our left pointer. And this is going to be greater than or equal to our left pointer. Those can potentially be overlapping. So anyways, so while the right pointer is greater than or equal to our left pointer, we're going to update our midpoint. So that is always just going to be the right pointer plus the left pointer divided by 2. That is the midpoint between those. And the first thing that we will check is if we have found our row, right? So how do we know that? So if the target is greater than or equal to matrix, let's see, if it's greater than or equal to the matrix at that mid row, the first element, right? So if it's greater than or equal to the first element and it's less than or equal to, it's going to be the exact same thing, but for the last element, right? So this is basically asking, okay, is the target, does it fall within this row, right? If it does, then we will just say did find equals true. And then we will break from this loop, okay? And then at that point, we'll go to the next loop, but we still have to finish the code for this. So the other case is, there's 2 other cases, right? So there's the one where target is, let's see, less than this first element, in which case we want to search the previous portion of the grid, right? So, and this shouldn't go here, but it should, this is the actual conditional, right? So if that's the case, to search the previous portion of the grid, we'll move the midpoint, which is, say the midpoint is at this row, right? We will need to assign the right pointer, which would be down here, to the midpoint -1, right? So we can just say right equals mid -1. And then the final remaining case here is if the target is greater than the last element of that mid row, in which case the left pointer will become the midpoint +1 to search the rest, the greater, the rest of the grid, right? So, okay, so at this point, we will have either found our row or we will have not found it. So I'll just do a check if we didn't find it. So if not did find, let's just return false, right? Because we didn't find the row. There's no point in doing the other binary search. We just, we know the target's not going to be there, right? Because it didn't fall within that range of that mid row, right? So otherwise, we want to do another binary search on all of the columns in that particular row that we found, right? So let's see. So we're going to have a row. Let's keep track of that with just assigning that to a new variable. Let's reset the left pointer to 0 and the right pointer to, this time it's going to be matrix. It will be the size of one of the rows of the matrix, right? That's how many columns are there. -1, right? For the last position because it's 0 indexed. And then we need to loop while our right pointer is greater than or equal to our left pointer. And we're going to update the midpoint. So this is the same code. And we're basically going to check. We can just do the exact comparison, right? Because this is like a regular binary search. Now that we're comparing elements, we can just say, okay, is the target equal to matrix at that row that we found? Is it equal to that? And the midpoint that we're on, if it is, then we've found the target, so we can return true. And then otherwise, for the other two cases, we're going to say, if the target is greater than, well, let's see, let's follow the pattern here. So if the target is less than the midpoint value, then we need to search the lower half of that row, right? So to search the lower portion, we need to move our right pointer down. So our right pointer will be equal to our midpoint minus 1. And then similarly, for the last case here, we want to search the greater elements of the row, right? So the top half of the row, and we do that by moving our left pointer to be 1 higher than whatever the midpoint was. So that should be it. We just have to return false at the very end of this. Just in case we don't actually find the element, right? We have to return false. But that's pretty much it. Aside from any bugs here. So if no member named first, so yes, that is valid. It is front to get the first element, the getter for the first element of a vector. First is for pairs, and really with first with the parentheses, I'm not even sure if that's not even correct. So anyways, yeah, hopefully that helps, and I'll see you guys in the next piece.